Hello everyone, in this video I am going to discuss about tricks to find out magnetic moment. For that we have to know the formula of the magnetic moment, which is represented by mu is equal to root over n into n plus 2, where this n is called the number of unpaired electrons. Okay, so here I have given some number of unpaired electrons here. The number of unpaired electrons is 1, and in that case the magnetic moment will be 1.73, and when the unpaired electrons is 2, the magnetic moment is 2.82. so when the unpaired electrons is 3.87, unpaired electrons 4, the magnetic moment is 4.89, unpaired electrons is 5.91. So whenever you see the number of unpaired electrons is 1, you can just directly choose the option of 1.73. so in that way 2.82. so we will make it more clear by taking an example or few examples. Okay, so let us take with the scandium. Okay, so scandium, Sc, the atomic number of scandium is, how much? It is 21. The electronic configuration of scandium will be argon 18, then we will write 4s2, so we write in this way 3d 20 up to this 18, 19, 20, 21. Okay, so now 3d has how many electrons? Has only 1 electrons. So d has how many blocks? 1, 2, 3, 4, 5. So how many electrons will be there? Only 1 electrons. So let us apply the formula of magnetic moment. Mu is equal to root over n into n plus 2. So where n is called what? The number of unpaired electrons. What is the number of unpaired electrons present here? It is 1. So 1. So 1 plus 2. So 1 plus 2 is what? 3. So 3 into 1 is 3. So the root 3 is 1.78. Okay, so whenever the unpaired electrons is 1, the value will be 1. Okay, 1 unpaired electrons, 1.78. It will start with 1.78. You have to remember this, 0.78. Okay, so let's take another one, that is titanium. The atomic number of titanium is 2. So let's write the electronic configuration. It is argon 18. Then we will start with 4s2, 3d 20 up to here 18, 19, 20, 21, 22. So let's, how many electrons are there in the orbital? So 2 electrons. So we'll draw the d electrons. So 1, 2. So unpaired electrons is 2. So we will apply the formula of magnetic moment, that is mu is equal to n into n plus 2, where n is called the number of unpaired electrons. So the number of unpaired electrons is, single electron is 1, 2. So 2 plus 2. 2 plus 2 is what? 4. So 4 2 is 8. So the answer is, how many unpaired electrons? 2. So 2 point root 8 is 2.82. So whenever the unpaired electron is 2, it will be 2 point, magnetic moment value will be 2.82. Next we'll try about the Fe. Plus 2. Okay, what is the atomic number of iron? The atomic number of iron is 26. Okay, we'll write with atomic number of iron is 26. The electronic configuration is Ar 18, then 4s2, 20 up to here 18, 19, 20. So 3d 6, 26. If I talk about Fe plus 2, then the electronic configuration will be what? Ar. This is scandium, iron is going to lose 2 electrons, so 2 electrons will be lost from here, and 3d 6, 4s0. Now how many unpaired electrons in the 3d? Let's see it, let's check it. So 3. Okay, so 1, 2, how many? 6 electrons? 3, 4, 5, 6. So how many unpaired electrons? 4 unpaired electrons. 4 unpaired electrons. So if I calculate the magnetic moment is equal to nu n plus 2. So the number of unpaired electron is 4. 4 plus 2, here it is 24, right? So how many unpaired electrons? It is 4, so 4.89. So the unpaired electrons is how much? 4. So 1 2 3 4. So the number unpaired magnetic moment also will be 4, so 4.89. So these are the table which will make us easy. Unpaired electrons 1, so 1.78. Unpaired electrons 1, so the value of root 3 is 1.78. Unpaired electrons is 2, 2.82. So whenever unpaired electron 2, the value is 2.82. Unpaired electrons 4, 1 2 3 4, it will magnetic moment will be 4.89. So the unit of magnetic moment is Bm, bar magneton. Okay, so with now by learning these values 1.73, it will make us easy to give the magnetic moment.